Hi, my name is Richard Holdsworth, Global Brand Manager for Power Products at Shell Lubricants. Over the last 5 years, Shell has been developing and testing a new oil for the transformer market, Shell Diala S4ZXi. As you know, customers in this segment are very knowledgeable about the industry and the oils they use in their transformer network. Products tend to be very technically led, and it can be quite intimidating selling transformer oils. This video is part of the Shell Diala Selling with Confidence program, aimed at increasing your knowledge so that you can sell the new Shell oil successfully. Specifically, the video will show a customer meeting taking place. It will tackle the difficult questions that customers may well ask, show a typical way the questions may be answered, and a best practice way of answering those questions. We're going to pause and analyse the conversation in stages, reviewing how the questions were answered, what went well, and what could be improved. By the end of the video, you should have a clear idea of how to answer 4 typical and difficult questions about our new oil to get the very best results from your customer engagement. So, let's join the sales call. We've already been through the selling stages of finding out customer needs at a previous meeting, and have now introduced and presented the new Shell Diala S4ZXi. We're at the point where you would ask the customer whether they have any questions they would like to ask you.
So to be clear, is the new Shell transformer oil a naphthenic type? And what's its performance like? In the past we've always used naphthenic oil.
That's a very good question. I'm glad you asked me that. It's a lovely new type of chemistry we have with these molecules. It's actually what's called an isoparaffinic product. So if you look at most of the transformer oils that are in the marketplace at the moment, they're typically composed of naphthenic, paraffinic and aromatic fractions. So if you look at the composition, you've got an aromatic PNA composition number that tells you the different products in there and the composition. With isoparaffinics, it's more than 90% isoparaffinic, which means you've got a regular hydrocarbon chain, plus it's been hydroisomerized to give you an iso branch point on the backbone, which means that at low temperatures, instead of regular molecules being able to pack together, which is what's called normal paraffins, these are isoparaffins, and it means they can't easily pack together, so they remain fluid at low temperatures. So let me show you the structure. As I say, it's an interesting chemistry. So if you look at the normal paraffins, you have regular hydrocarbon chains that have this regular structure and packed together at low temperatures, tend to be solids. If you look at the isoparaffinic, you've got a regular hydrocarbon chain which has been hydroisomerized, so they've actually got methyl side chains on the backbone of the structure, which means that low temperatures it doesn't pack together very easily, whereas normal paraffins do. And if you look at the normal naphthenic in the marketplace, you tend to have a saturated hydrocarbon ring or a number of rings joined together, as I'm sure you're aware.
So, let's consider how we might improve upon the answer you have just heard. There are several points to answering this question, and a mistake is not to point this out to the customer and to answer each separate point in turn. It is important to answer the question in a structured way. Highlight to the customer which parts of the question you are addressing and summarise the key points you are making, focusing on how they benefit the customer. Don't get tied up in the features of the grades, rather than focusing in on the benefits and performance that the new GTL isoparaffinic grades provide. Don't forget to ask questions to qualify the question and probe the customer's needs so that you can answer the question in a relevant manner and informative way for the customer. Okay, so now let's take a look at how it could be done.
So to be clear, is the new Shell transformer oil a naphthenic type? And what's its performance like? We've always used naphthenic oils in the past.
Okay, good question. I think there's 2 parts to that. One which is about the composition of the product. Is it naphthenic? And the other question is about the performance. So to start with the naphthenic question, the new Shell Diala oil is based upon GTL gas to liquid technology, and that means that it's actually isoparaffinic. This is a new molecule that we've developed ourselves, and it gives us consistency and reliability in terms of the molecular structure. This actually contrasts quite strongly with naphthenic grades, which are produced by refining crude oil, where you have this mixture of naphthenic molecules, paraffinic molecules and aromatic molecules. And that mixture can actually vary depending on which crude oil source you use and how you refine the product. But that's about the composition. I guess what we should be talking about more is what the product's going to give to you and what sort of performance you're looking for. So in terms of performance, are there any particular areas that you're focusing on?
Well, some of our transformers have to operate in very low temperature conditions, so that's why the naphthenic properties are important to us.
Okay, that's an interesting point. So traditional paraffinic grades have not really been favoured for low temperature properties, and that's one of the reasons that manufacturers such as ourselves have gone for naphthenics, which do offer excellent low temperature properties. With GTL, it's got a nicer paraffinic structure, which actually means that its low temperature properties are actually quite similar to naphthenic grades. Its pour point meets all of the IEC standards, and actually its low temperature viscometrics, so in a kind of more normal operating range of say between about -10 and -25, that's actually better than something like a Diala S3ZXi, which is one of our naphthenic grades today. So I think in terms of low temperature applications, you shouldn't have any problems using the new product.
So let's recap on what was important to remember. So, having fully addressed the question, let's continue with the core.
You talk about the GTL process and how it produces oil that's more consistent and reliable. How do you know that it'll work for my transformers?
Good question. I'm glad you've asked me that. We've got over 30 years of research and development developing the gas to liquids plant. We've invested some 20 billion. So basically it's a process that we know well. We take natural gas, we clean it up, we then oxidize that in the presence of oxygen. So we've got enormous compressors to liquefy and compress oxygen from the air. We then convert the methane to carbon monoxide. We then take that carbon monoxide, add in hydrogen, make synthesis gas. We then do the Fischer-Tropsch reaction, convert that to normal paraffins. And then once we have the normal paraffins, we hydroisomerize that to the gas to liquids product. So you've got a very good, robust shell product that you can trust and believe in.
Let's talk about how that answer could be improved. First of all, demonstrate that you understand the customer's issues and needs, and use relevant information to show how Shell is addressing these. For example, what's in it for them? How does it help them? Very importantly, use personal pronouns. Words like you, our, your, we. This makes your answer feel specific to the customer's problems, not generic to everybody. Make sure you use proof points to qualify what you are saying. And use straightforward language, not industry jargon and shell speak. So let's take another look at how we can answer that question.
So you talk about the GTL process and how it produces oil that's more consistent and reliable, but how do I know it's going to work in my transformers?
That's a good question. It's natural that you would seek reassurance in introducing a new grade to your transformers. I think the first thing that I would say is that we as Shell have been supplying transformer oils under the Diala brand for more than 50 years. So we've been working with different OEMs, transformer manufacturers, as well as the utility companies for that time. We understand the severity of the application and we understand the consequences if something was to go wrong. So before we've brought this product to market, we have done two pieces of work. Firstly, we've done extensive kind of internal R&D work to make sure that the product meets the requirements that you would expect from it. We've done a lot of thermal modelling. We've done a lot of work to look at the lifetime performance of the oil, different aging tests, and we've also done an extensive suite of electrical testing. And again, we can share that information with you. We have third-party validations from laboratories such as Laborelec in Europe and Doble in the States who've given us data to support what we're saying. There are other manufacturers and some utilities have also approved the product so far. The other thing that we have done is we've spent a lot of time looking at our manufacturing processes to make sure that when we produce the product, we produce it in a consistent and reliable way. So I guess the question would be, do you have any specific kind of test requirements or tests that you're interested in?
I do have some concerns about sulfur-related copper corrosion, and there's been some problems in the industry with that. Does your new product pass all of the latest specifications and tests for copper corrosion?
That's one of the easier questions, actually. Yes, I mean, absolutely it passes all of the latest tests for copper corrosion. And the reason behind that relates back to the product itself. So with the gas to liquid process, we can say there is effectively zero sulfur in the product at all. So actually, if you look for sulfur in there, it's very, very unlikely to be able to detect any. And that contrasts very strongly to the mineral-based grades, which all contain some level of sulfur. So an uninhibited grade would be perhaps 300 to 400 ppm, whereas an inhibited grade would be perhaps 40 ppm. With us, we can say it's effectively zero.
So the important points to remember in answering a question like that are: So let's look at another likely question you'll be asked.
Well, there is another issue I have from what I've heard about the new oil. It's inhibited and we only use uninhibited grades. They've given us no problem in the past, so why should I change now?
Uninhibited oils have been used for a long time historically. Typically they've got weaknesses such as producing sludges and deposits because they tend to be impure. They've got lots of things like sulfur compounds within them. In our experience, talking to other customers and competitors, the movement in the marketplace is towards inhibited grades, and that's something we firmly believe in. We see more benefits towards moving towards inhibited grades. So I would ignore the uninhibited products and very much focus on the inhibited grades.
So how can we improve upon this answer? First of all, make your points clearly and straightforwardly. Remember, the more complex the issue, the more straightforward and structured your answer should be. Think about how you'll explain something before you go into the meeting. Don't forget to speak slowly when explaining complex material. Slow down when you are making key points that you want your customer to remember. And make sure you provide evidence to support what you are saying so that your customer can not just turn around and say, "So what?" or "Why should I believe you?" How can we answer that question, taking these points on board?
I do have another issue from what I've heard about this new oil. It's inhibited and we only use uninhibited oil. It's given us no problems in the past, so why should I change now?
I think what I'd like to do is talk about why we've gone down the inhibited route. And again, I'd like to explore a little bit further kind of any issues that you would have in terms of changing. So in terms of the inhibited route that we've taken, I mean, we have done that in line, I think, with general industry thinking. So what we have seen in terms of trends from transformer design is that manufacturers are increasing the voltages in the transformers. Transformers themselves are getting smaller, so you're getting more sort of stress on a smaller volume of oil. And actually the expectation from utility companies is that those transformers are going to be lasting longer. They're expecting them to last for perhaps 30, 40 or even more years in the field. And for that, the inhibited oil seems to be the way to go. The reason for that is that the inhibited oils tend to be more refined, and the addition of the artificial antioxidant means that in terms of degradation, so acid production, sludge production, and so on and so forth, that happens much more slowly over time. That's why we've gone for these inhibited grades with GTL. But I guess what I'd like to understand from you is you say you use uninhibited oils today. I mean, what would stop you moving to an inhibited grade, or what issues or challenges do you see there?
Are there any changes in maintenance requirements or condition monitoring schedules?
This is a common concern from utility companies where you have a number of transformers in your fleet with uninhibited grades. So I guess what you're doing today is you're using a sort of total acid number type approach, where you're very used to kind of seeing that increasing quite sort of slowly over time as the oil ages. With inhibited grades, you can use the same approach, but actually because the inhibitor works so well, you'll see a very, very, very slow increase in total acid number. So what we tend to recommend, and what actually most people do, is they look at an inhibitor measurement. So you can actually look at the oil and you can see how much inhibitor is in there. And then as that starts to drop, you can then choose to change the oil, or you can add inhibitor to it, and that will give you the performance that you need. And that guarantee that the life is going to carry on as you expect. And one thing I guess is worth pointing out that this march towards inhibited oils is very much global. So we see in countries such as the US and China, they are actually completely on inhibited oils today. And again, we see that trend continuing very much over the coming years.
The important points to remember are: the final question for us to address is:
This new GTL process and technology sounds expensive. Why should I pay more for a transformer oil? The one I'm using now is doing a decent job for me.
I have to agree with you, it is an expensive product, but if you look at the costs for Shell of developing the product in-house, we've got over 5 years R&D costs we need to recoup. We've got the investment costs of our GTL plant that's cost over $20 billion. So there are a lot of costs behind the product development. But if you look at the features of the product, you've got things like low temperature viscosity, you've got a high flash point. All of these are actually worth buying and paying for. So our belief is this is a desirable product and we expect you as the customer to buy it.
Again, let's talk about what we can do better. Don't talk around price, address it. If the question has been asked about price, answer it. Remember, talk about benefits and value. Value is what the customer will receive over and above the price they pay for their transformer oil. It relates to cost savings that will reach far beyond the price of the transformer oil. For example, savings on servicing and future breakdowns, longer life of equipment. Check you have answered the question in a satisfactory way for the customer and met their needs. A better way to answer this question would be:
This new GTL process and technology sounds expensive. As a major transformer OEM, we buy an awful lot of this kind of oil. Why should I pay more for a transformer oil when the one I'm using at the moment is doing a decent job?
I think, we understand the part that transformer oils play in your sort of total cost of goods, and rest assured that the new GTL Diala grades will be competitively priced. But what I could say is that you're going to get this product which offers exceptional benefits, such as we've talked about oil degradation, resistance to degradation, and the life expectancy of the oil. We've talked about the very, very low sulfur, effectively zero sulfur. We've talked about excellent thermal and viscometric properties. All of these are features that you can use in discussions with your customers, and those customers are expecting your transformers, which are getting a higher voltage and they're getting smaller, they're expecting those transformers to last reliably for longer. So again, I think those are all arguments that you can have with your customer, and we can have those as well jointly. I think the other thing I would say is that, in future we can work together to look at opportunities where we can optimize the design of your transformers and perhaps look to take costs in some of the other materials. And again, that could be an area for future cooperation. The other thing to think about is our future strategy. So with our investment in the GTL plant, we're investing in gas, and that means that we have an excellent long-term supply position, which I think should be interesting to you because we offer a reliable supply and a consistent supply, and that consistency will be globally available. So methane is methane, whether it's in Asia, Europe or America. So our product is going to be the same everywhere. I think I would contrast that to, and we've seen this ourselves with naphthenic grades, where crude is getting increasingly difficult to source, and we're seeing increasing amounts of variability in those products. So I think looking at the GTL grades in future, you are looking at a long-term solution to this issue of availability. So I think what I'd like to do is we should follow this up and talk about an exact kind of price for you. So what I would suggest is that we follow up with a conversation about talking about the volumes that you're interested in, and then we can make you a competitive offer.
So it's important to
In this short video, we've looked in detail at 4 typical questions that you will be asked. But whatever the question, there are 3 points to remember. Number 1, check. Check that you've understood the question. Repeat it back, break it down, and if there are multiple parts, make sure it's clear which part you're answering for your customer. Number 2, verify. Make sure that you probe for details. What specifically is a problem for them? What are their particular needs? Do they have old transformers in their stock? Are they operating at low temperatures? Do they have worries about mixing or concerns about inhibited oils? Number 3, be benefit focused. Think about how the oil benefits the customer. Instead of simply concentrating on the technical features, make sure that you make the connection with how and why the features benefit the customer. So to recap, check, verify, and be benefit focused. Thank you very much for watching, and good luck with those sales calls.